This video is going to be focusing on the idea that sometimes when we are solving a quadratic, right now we've been doing factoring mostly, what happens if it's not factorable, or when I'm solving by using square roots like we've done already, what happens when I get something like x squared equals -5? How do I deal with that? We have these things called complex numbers. You might also hear them called imaginary numbers. Okay, complex simply means that it has a real part and what we call this imaginary part. We're going to talk about an imaginary unit, lowercase I. I is represented by the square root of -1. So the big thing here, I squared is equal to -1. Okay, so we're going to be looking at solving and the idea that sometimes we get imaginary solutions, and then eventually working on when we start looking at these things graphically, what do imaginary solutions actually mean when we are finding our solutions pictorially. So let's just start with simplification using our rules that we did with simplifying square roots and rationalizing and all of that, except now we're dealing with square roots of negative numbers. So you want to treat, right now I've got the square root of -49. Okay, so let's treat that as the square root of -1 times the square root of +49. Okay, so the square root of +49 is 7, and we said a second ago that the square root of -1 is I. So I'm going to call this 7i. It's not plus or minus because we didn't physically take the square root, it was already there for us. Okay, we still use the same simplification processes that we did before. So I've got the square root of -1 for the next one times the square root of 18. So I'm going to simplify the square root of 18. I'm going to call the square root of -1 I. Square root of 18 goes to the square root of 9 times the square root of 2. So that's 3 square root of 2. So we just write that as 3i square root of 2. Okay. And then let's see the next one for C. With division, remember we said that we can take the derivative of the top over the square root of the top over the square root of the bottom. Sorry, I got into calculus speak there for a second. Okay, so in order to simplify this, square root of 2 is not possible to simplify. The negative I can pull out with the I. So that's going to give me I times the square root of 2. But I need to rationalize the bottom. Square root of 3 also is not simplifiable. So I'm going to rationalize by multiplying both the top and the bottom by square root of 3. Square root of 3 times square root of 3 in the bottom gives me 3. So all in all, I have I. Square root of 2 times square root of 3 is the same thing as the square root of 6 over 3. Now square root of 6 is not simplifiable, so I can't do anything with it. So I would be done there. Let's switch colors here so that we're not getting too confused here. Okay, so another division, I've got the square root of -1 over the square root of 100. Square root of -1 is I. Square root of 100 is 10. So the last one is I over 10, or you could write that as 1/10 I. Okay, so we can also then, now that we know how to simplify, we can solve some quadratics. We're going to do it by square roots. Okay. So first thing I need to do for these is get the x squared by itself. So first I'm going to subtract 11 from both sides. That gives me 2x squared. Oh my, sorry. Let's try again. Sometimes this pen is a little finicky. So I get 2x squared. -37 minus 11 is going to give me -48. And then I'm going to divide both sides by 2. So I get x squared equals -24. This is where the plus or minus comes into play, because I physically have to take this the square root of both sides. So now I've got x is equal to plus or minus, and I'm going to split the square root of negative 24. Okay, so I've got the negative automatically becomes I because you have square root of negative 1 in there. And then I'm going to split the square root of 24 into the square root of 4 times the square root of 6. So my final answer, I get plus or minus. Square root of 4 is 2, so I'm going to put the 2 in front of the I. And square root of 6 cannot be simplified. Okay, let's look at the next one. I want to get x squared by itself, so I'm going to subtract 13 from both sides. So I get x squared equals negative 13. I don't have to do anything else to simplify it except take the square root. So that gives me x is equal to plus or minus, since I physically took the square root of both sides. The negative becomes an I, and square root of 13 is not simplifiable. So my solutions are positive I times square root of 13 and negative I times the square root of 13. All right, last one in this group. Again, I want to get x squared by itself, so I'm going to first subtract 33 from both sides to give me negative 30. Then I'm going to divide both sides by 5 to give me negative 6. Take the square root of both sides. So I get x is equal to plus or minus. Since it has a negative under there, I bring out the I, and square root of 6 is not simplifiable, so I just leave it as square root of 6. So I have I times square root of 6 and negative I times square root of 6 as my solutions. Okay, let's get a little bit more complicated. So we're going to talk about complex numbers. Okay, a complex number is in the form a plus bi, okay, where b could be a negative number, so it's actually a minus bi. A and b are real numbers. A is considered the real part, and the number bi is the imaginary part. Okay, so we're just going to look at some operations with them first, and some rationalization with them, because eventually we're going to be getting complex numbers like this as our complete answer. So let's first start with sum, difference, and multiplication. So sum and difference, you're going to combine the real parts and the imaginary parts. Okay, so what do I mean by that? So in this case, the 8 and the 5 are considered the real parts. They are separated by a plus sign. So I'm going to do 8 plus 5. 8 plus 5 is 13. And then my imaginary parts are the negative I plus the 4i. So that's going to give me negative 1i plus 4i, which is a total of positive 3i. So my complex number in standard form is 13 plus 3i. Okay, now if I look at subtraction, so I'm going to do 7 minus 3. So that's going to give me 4. And I'm going to do negative 6i minus 4i to give me negative 10i. Okay, so now if I look at, if I had given you a problem, I'm going to take the same one, and I'm just going to add one level of difficulty to it. Okay, if I'd put a 2 out in front, I'm going to first carry the 2 through, so that makes this 7 minus 6i minus, okay, I'm going to carry just the 2 through, 6 plus 8i. So I would do 7 minus 6, which is 1, and then the negative 6i minus 8. So negative 6 minus 8 would have given me negative 14i. Okay, so you can have multipliers out, and you just multiply them through and then continue on. All right, let's look at multiplication here real quick. I'm going to scroll down here. So I've got 2i times 8 minus 3i. So I'm just going to rewrite what I have. Okay, so I can use the distributive property for this. So I'm going to carry the 2i multiplied by 8 and the 2i by the negative 3i. So 2i times 8 is going to give me 16. 2 times 8 is 16i. Then I'm going to get minus 2 times 3 is 6. I times I is I squared. Now if you remember back, where is it? Here, we said that I squared is equal to negative 1. So you have 16I minus 6 times negative 1. So that's 16I plus 6. And we can reorder it so it looks like we're used to 6 plus 16I. Okay. Alright, so then I'm going to do 2 minus 3I times 5 plus 4I, and you know how I like doing the box stuff for multiplying. I've got 2 by 2, 2 terms times 2 terms, so I'm going to make a 2 by 2 box, 2 minus 3I, 5 plus 4I, and I'm going to multiply. So I've got 5 times 2 is 10, 5 times negative 3I is negative 15I, 2 times 4I is 8I, and 4 times negative 3 is negative 12, and I times I is I squared, which we said is negative 1. I'll just put that down here for reference for you. Alright, so basically I've got 10 minus 15I plus 8I, and then I've got negative 12 times negative 1 is plus 12. So 10 plus 12 is 22. Negative 15 plus 8I is negative 7I. Last but not least, we look at rationalizing. So before, when we rationalized, we multiplied by whatever the square root was, or we used the conjugate. And the conjugate was multiplying by this, what was ever in the denominator, and switching the signs. So we're going to do the same thing. I'm going to multiply by the conjugate of 2 minus 3I, because we don't want i's left in the bottom. So I'm going to multiply top and bottom by the conjugate of the bottom. Okay, so I've got 6 times 2 plus 3i, so I can carry the 6 through, and that's going to give me 12 plus 18i. And then I need to multiply, we'll do that over here, 2 minus 3i and 2 plus 3i. So that's going to give me 2 times 2 is 4. 2 times negative 3i is negative 6i. 2 times positive 3i is positive 6i. And then I get negative 9i squared. I squared being negative 1, so this is going to become positive 9. So these cancel, and I get 4 plus 9 is 13. Okay. If all three of these pieces had been divisible by some common term, I would have gone ahead and done that, but these ones are not. So I'm done. All right, for the second one, again, I'm going to multiply by the conjugate, which is 1 plus 4i. So I'm going to multiply the top and bottom by that. And it looks like I need to do 2 different boxes, so let's do the first one over here. I've got 3 plus 5i and 1 plus 4i, so that's going to give me 3, 5i, 12i, and 20i squared, so that's negative 20. Alright, so my top is going to be 3 minus 20 is negative 17, and 5i plus 12i is plus 17i. Okay, and then my denominator, I've got 1 minus 4i times 1 plus 4i. So 1 times 1 is 1, negative 4i, positive 4i, and then I've got negative 4 times 4 is negative 16. I squared is negative 1, so it's going to give me positive 16. So it looks like these cancel out, and I get 17 in the bottom. Now I notice that all three of these pieces are divisible by 17, so when I do that, I'm going to get negative 1 plus 1i over 1. So it simplifies to negative 1 plus I. Alright, so I would like you to do the last one and bring it into class for homework.